So we're starting with Databricks, but we're probably just Yes, thanks.
G'day. My name is Bill Constantinis. I'm the last person in Sydney City to be wearing a tie. So, so don't think I'm doing this special. I do this every day, except for weekends. I'm actually on the organising committee for Data Science Sydney, and I'm also part of the Institute of Actuaries Data Science Practice Committee. For those who don't know what an actuary is, just a brief summary. So people just might not know, but an actuary theoretically is good at maths. We work mainly in the financial services and insurance industries. A lot of our work is around pricing, estimating capital needs of companies, provisioning for liabilities, and basically general custodians of the financials. Analytics is really core to what we do, and that's one of the reasons why we've welcomed Data Science Sydney into our offices. Welcome everyone to Data Science Sydney, or Sydney Data Science Meetup. New venue and a new sponsor. The Institute of Actuaries CEO Elaine Grace sends her apologies. She's in Brisbane today, but hopes to meet you all at the future event. The Actuaries Institute is delighted to be hosting these meetups, as data science is a key part of actuarial work and is an important part of our future strategy. The Institute of Actuaries has a strong data science community led by the Data Science Practice Committee. I'm a member of that as well. That comes together to create debate and thought leadership around large trends and to bring together best practice methodologies analysis. And a lot of the big issues are emerging, including things like ethics and AI, trying to address some of that those thought pieces and how do we handle them. Data scientists and actuaries work closely with each other. It's great to bring these two communities together. Just before I start introducing people, if anyone wants to know where the toilets are, they're just to the left down the corridor. This is being recorded as well for later viewing for people, so it's not a live recording. So just to let you know, if you're not comfortable about saying things on video. Also, we'd ask people to, when they've got a question, to actually wait for the mic to come to them so we can hear. There will be a break at 7 o'clock for 10 minutes for a toilet break. In terms of speakers today, we have two great speakers, and that's Dmitry Semenovich and Eugene Debasarski. Dimitri's talk will be the last 10 years in enterprise data science, while Eugene's talk will be data science 3 years on, ChatGPT, some use cases and implications. In terms of a biography for these two very learned individuals, Dmitry is currently the head of analytics at CoverGenius, an embedded insurance provider to tech companies. He has a particular interest in the advancement of practical actuarial methodology and its realignment with modern optimization and machine learning. His other interests are in market design and risk theory. Dmitry has a PhD in computer science. I suppose that's Dr. Dmitry then. Anyway, Eugene is head of Data Science Sydney. He's been practicing commercial machine learning and data science for 27 years. He's a trainer, consultant, and entrepreneur with a number of organizations where he's a director, founder, or partner. He holds a PhD also in computer science with a thesis in neural networks. With that, I'd like to invite Dimitri to the podium and to give his talk. Thank you.
All right. Well, thank you, Bill, and thanks to the Institute of Actuaries for hosting this event. As you can see, Eugene and I haven't really coordinated because our time frames strangely overlap, right? So after I heard that Eugene was going to talk about ChatGPT, I thought I'll kind of serve as a warm-up act and just kind of reflect a little bit on where, I guess, data science, kind of where it has come from, or kind of the main things that have happened. And so we can, I guess, speculate about what might be in store for us in the, like, do we have that? So we probably do just. Okay, so my talk has two parts. One is we talk about the last 10 years, and again, the second part is very brief. We talk about the next 10 years. Maybe ambitious. So, okay, so just a few, again, they're very general stuff. So what has defined data science? And I'll talk about these in a bit more detail later on. So really well, it has all come from, arguably, it's kind of the success of online advertising. So the kind of the successful first successful business model, second business model in consumer tech that kind of caused all that, in the early 2000s, the Google IPO, the rapid takeoff of consumer technology companies. So between the tech companies, I guess, if you were to reflect back, like a lot of stuff that data scientists do, or at least data scientists in product teams, they just mostly do A/B testing. Like that's sometimes, well, if the tech company is lucky enough to have a product, they do A/B testing. If there's no product, then they work on the product so that there is a product, so that they can do A/B testing later. That's the usual kind of pattern, but it's kind of a big part of what it is. That kind of separately, the big data thing has happened. I guess it was largely powered by success of online advertising providers, or really some technology that were created. Kind of machine learning was happening in parallel through the academic kind of discipline that was probably picked up by online advertisers. And artificial intelligence, I mean, that's been going on for even much longer than machine learning as a research area. But it was really with, I guess, 2012 when deep learning has come back, and then we've seen a steady kind of stream of increasingly more impressive announcements kind of over the years, culminating, I guess, ChatGPT of being chat. So any talk like this at a meetup, it has to have a Google Trends slide. So that's what I've learned. So we have the so this is from 2004 until 2023, and we can kind of see that similar story. We have artificial intelligence that was kind of declining in popularity, really, with machine learning may or may not have been picking up, but then we had in around 2012 a rapid takeoff of big data, probably due to, well, I guess Facebook IPO was around the same time, probably some articles in business press and so on. Data science really kind of coincided, kind of slow up ramp, but coincided, kind of followed with that. Okay, now just on the, like if we think about the cause, if we want to look for the true cause of the rise of data science, well, at least one of the causes is the rise of, again, online advertising as the business model, which created a lot of money to spend on open source and open source tools, necessitated open source tools like web scale applications to deliver, to serve online advertising, or maybe the causality there was the other way around. But it's really, you can see the inflection point. I mean, with the kind of as AdWords was taking off, was around 2004. That's when Google IPO'd, and then we have that's when mobile phones, kind of you got iPhone took off. So it's another potentially secondary inflection point. And it's at some point the whole ecosystem has really eclipsed all the legacy advertising, and a lot of this money from digital advertising and from venture capitalists looking to replicate the success went back into technology development, into developing tools for data analysis. So I mean, if we were to reflect back on consumer tech as a whole, I mean, you had probably some of the big success, or at least persistent success stories, or probably like going back to the 90s that are still around would probably be eBay and Amazon. So really online marketplaces solving, basically replacing the newspaper classifieds or the catalog. So that was one big part. That's not really heavily advertising focused. It's really more matching with buyers and sellers, but it's really with AdWords when we got into the and capture search, again being a great replacement for phone directories and all sorts of things, capturing the customer intent, you know, and the moment somebody searches for something, being a great time to serve them the ad. I mean, that was really the, I guess, the economic engine that has, I guess, created the big data movement. Now, obviously, the companies providing search, I mean, they need to crawl the web, they need to maintain the index, they need to crawl the web and so on. So they have big data that they need to store and index to deliver their product. They don't need critically big data to deliver the AdWords. AdWords is completely independent of big data. The simplest keyword match will be just as successful as anything else. But that's a secondary, it's something to keep in mind, because somehow what as part of kind of public consciousness of kind of broader thinking about online advertising, somehow it was all about personalization. So the so if you had to, I guess if you ask somebody 2012, what is big data going to deliver for you? People would say, you know, we'll be able to personalize things, our services, and unlock economic value, perhaps. However, again, and in some sense, like web search does deliver personalization, as in it delivers results based on the query that you've submitted, but it's really a stretch from there to, first of all, there are a lot of web pages, and most companies have very few products. So there is a, but anyways, so that's that particular side of things was a little difficult, perhaps. But before we'll come back to personalization and big data. But the second thing, I guess, where some of the, I guess, cachet or initial kind of prestige for data science has come from is like once people had these, well, basically websites, at the time there were websites with serving a large number of customers, you know, millions of visits per day, you could really kind of fundamentally start thinking differently about how you run your essentially software development cycle. So if you're a product manager on some feature at a consumer tech company, instead of just building and releasing features, what you could do is, well, you could build the new feature and then you could switch the traffic between the original version of your site and the new feature you built, and look at the key metrics that your team is tasked with improving. So the KPI. So that's kind of, and when you think about it, doing this kind of randomized control trials without outside of kind of web environment is a lot harder than you might think, right? It's not like so very few. Like you need to, I don't even know if you have a catalog, I guess you have to send different people. But I suppose you could do it with catalogs, but it's somehow it wasn't really done. So not in the general business. But here you essentially got A/B testing as a byproduct of your kind of just software development life cycle. For no other reason than it's always safer to release your change to some fraction of the traffic and see if anything broke, rather than even to try and optimize. But it's a very, very effective. And again, a lot of what we call data science people worked on this sort of product improvements. It wasn't really personalization or recommendation or anything like that. It's just doing basically online ABC controlled experiments. It's still fair number of, again, data scientists who work in consumer tech, who are lucky enough to work for a company that has a product. That's what they do. And it delivers genuine, even though the scope of the questions you can ask with A/B tests are quite limited, it still delivers a genuine uplift in the sense you can maybe get 10-20% over what you would have gotten otherwise. I mean, it kind of flattens out and so on. Eventually, kind of this digital A/B testing has made its way into other areas of the economy, So now pretty much every consumer or company financial company has some sort of fairly heavy digital app presence, and people kind of move around and they do A/B testing kind of on the edges. That's pretty common. I mean, it's quite rare to see some sort of more in-depth A/B tests to do with product. But to be fair, we haven't really seen a lot of product changes from tech companies either. So, like once your experimentation program becomes sufficiently mature, most of your tests fail. So that just becomes very draining on just the people involved, because you have like 80% failure rate, and like, oh, try it. Yeah, so the pressure is very high to stop measuring or to do something else. Okay, so big data again. So that was, I guess, more in Australia. I think big data kind of 2012 was probably the year of big data, when a lot of large companies have started asking the question of what are we doing about the big data. And I guess the way I define big data is, you remember the 5 V's? I don't remember the 5 V's, but okay. So my definition is that big data is the hypothesis that loading all of the company's data into an analytics database will unlock significant economic value. That seems to be the big data hypothesis. Usually people add via personalization. Right? But that's sometimes if you press exactly how it is going to happen. Like again, and it sounds reasonable on kind of on face value. It's a pretty reasonable theory. The big data hypothesis is it was worth a try. It was worth a try. And also at that time, the open source projects, I guess mainly Hadoop. People remember Hadoop. Have made it, at least Hadoop was a lot cheaper than Teradata. So you could have a go actually at doing that, and let's see what happens. And within, again, larger enterprises, these would have been relatively small projects, so or medium-sized projects, so nothing extraordinary. Like early tech had some real serious usability hurdles, like the early conversations around data science was this, like the full stack data scientist, I guess, who could write production Java code, has to run scoring on Hadoop. So I mean, these days, like I reckon the big data problem has effectively been solved. Like if you look at the cloud hosted stuff like a BigQuery or Redshift or things like that, these are essentially the SQL databases that are kind of managed for you mostly. And it's really just like working with a single SQL database. It's very fast, and the costs like really quite low. Like for this, at least if you're operating on the scale of several terabytes, the costs sound great. So, but these tools are have gotten very good, and I think the big data problem has effectively disappeared for vast majority of users. You're just using essentially SQL with good support for window functions and stuff like that, and you do your and I guess with other tools like the DBT, you have your table provenance, and you can see it all where it came from. It seems like actually in a pretty great state compared to where things were. So big data has kind of been falling off. Again, a lot of money was spent on big data. There are a lot of vendors, many of whom probably would not survive. I don't expect any Spark-based solutions to survive. But it's.
What about Databricks?
Spark solution.
Yeah. Double down.
Anyway, so the machine learning is another thing, right? So it started out as like a splinter group in AI, where some AI researchers wanted to make, they wanted to work with real data instead of with less real data or made up rules. So that would probably be, I guess, probably the 80s when it started, kind of in computer science. There was a lot of good progress all throughout the 90s. The tech companies kind of picked up a lot of kind of machine learning work, built out in-house labs. So probably the primary problems were sort of large-scale supervised learning, some reinforcement learning. I mean, I don't know to what degree, but supervised learning as a primitive kind of at scales definitely was used a lot. I mean, you've got some pretty good tools coming out of that, like the caching, featureizer, so something like that. So some sort of ideas that people without sort of computer science background kind of trying to apply definitely wouldn't have thought of. Again, machine learning kind of culture had a strong emphasis on empirical model verification, which is just a fancy name for out of sample testing. So you could have like competitions, or in general, you could, within the academic literature, you could compete for state-of-the-art results. So that's created generally some pressure to develop methods that at least within the supervised learning paradigm work well. And I guess gradually machine learning kind of community-derived software has displaced statistical software. So it's like, if we look at ProgGLM versus scikit-learn, I think how that one went. So people don't reach out to the trusty ProgGLM. anymore. So that was good. I mean, there was a lot of pretty strong success for machine learning in practice, like in most areas, like tools that kind of, even though they're really mostly the same tools, but the tools built by the machine learning community kind of replaced the statistical software, which itself by that point was probably 30 years old. Okay, so it's good progress in machine learning, at least really taking over the applied areas. And finally, artificial intelligence is again very long-standing area of research. By kind of 2010, it was very much out of fashion. Everyone, like the cool people, everyone was talking about like they're doing machine learning at the time. Then it's all kind of changed around. Well, 2012 was the year when it all changed. People went back to neural networks, and really by now, all the whatever used to be machine learning venues, they all almost entirely consist of deep learning, gradient descent, some variations on the architectures. And I mean, from 2012, we've seen a pretty steady kind of stream of improvements on perception tasks. That's voice recognition, computer vision. There's obviously big breakthroughs in two-player games, and somewhere say around 2017, 2018, AI has gradually replaced big data. So before, everything that people were doing was about big data hypothesis, and then it became about artificial intelligence. Now, I don't think the final mechanism for like activation has changed. I think AI was still meant to deliver personalization, same as big data. I'm not entirely sure how that worked, but it's definitely much less talk about big data and much more talking about artificial intelligence. Like in the enterprise, if you're working in outside of AI research environment, or kind of startups working on AI-derived products, it would have probably had pretty small impact on what you were doing. Like some of the, I would say speech improvements in speech transcription, or probably, if you have call center data, maybe but more accurate call center transcripts. We saw launch of the IVR systems that are, I guess, not button operated. There have been obviously improvements in working with image data, especially with aerial photography, and kind of that became more democratic. It was easier to get features derived from that. And I guess a lot of funding in the AI kind of 2015, kind of in that era, went into self-driving cars. So self-driving cars might still be happening, but maybe next. I mean, like people are working on, connecting. Well, maybe if we integrate ChatGPT, self-driving, maybe that'll solve the world model problem. So there's, yes, so there's also hope. So like if you wanted to, I don't know, what's a good terminology, but some of the quotes that kind of seemed relevant at the time, like if people ask you what you think about AI, like the first used to be a good quote, if you can do a mental task with less than 1 second of thought, we can probably automate it. I mean, and it's probably still true. It's just turned out to be less useful than we think. Like the second comment is better, the new one, this one's still current, the second one. So pretty much all, if you didn't learn anything about deep learning, in the last 10 years, well, you didn't need to, because the only thing that matters is transformers. So that's pretty great. So pretty much all of the state-of-the-art architectures now for most tasks are transformer-based, or at least you can find a transformer-based one that's close to state-of-the-art. So so that's anyway, that's useful to know if you want to quickly catch up. Okay, so that was the those were the main kind of things to cover. That was, I guess, the last 10 years. So big data waves receded. The online experimentation hasn't truly taken off in like outside of tech companies' product teams yet, but it might. And big data, yeah, big data tools got really great. Machine learning, I guess, everybody's now using machine learning algorithms for everything. And AI we are on the verge of, I guess, a very big change in AI with large language models that I think Eugene's gonna talk about. So if ChatGPT hasn't happened, right? Like the angle on the this is something like what I would say about what might be like the next 10 years of data science. And it's really thinking about data science as really it's a majority of use cases are that have any money in them, I guess. The quantitative social science use cases where you try to estimate the impact of whatever on people. Usually those are causal questions. So experimentation is one form, but often experimentation isn't feasible. In quantitative social sciences, it isn't feasible either. So people have come up with a wide range of methods of different degree of implausibility for coming up with plausible estimates in the absence of experiments. You have to ask yourself, how much better things could be if we really went and did experiments on some actual important questions. Yeah, there's no risk of it happening anytime soon. So in the meantime, there is a plethora of, methodologies which you can adopt to try to get at the approximate answers. One last thing is that unfortunately, I guess computer science in particular, the causal graphs kind of, I think, has done a real disservice to applied causal inference just because that literature doesn't have a lot of practical examples and you're very likely to walk away confused. So check out the, I don't know, probably methods from econometrics like, I don't know, I guess difference in difference or similar methods. Those are very, you get a lot of time series. I think there's a link in the slides. There isn't, never mind. So this should work. I think if I go out of this mode, there is a link. So, okay, however, right, so that was just some wishful thinking. We should start thinking more about causal inference and pick up some tools from econometrics where we can do experiments. However, remember those data science, artificial intelligence. Well, this is ChatGPT. So the paradigm has been completely altered, right? We don't have the, so all of those things have really been pushed into maybe irrelevance, right? So here is the new paradigm, right? If you work as hard as you can for a full year, you're only going to output $264 worth of tokens. So I'll leave you here for Eugene to pick up the ChatGPT theme.
Yeah, no, thank you, Dimitri. No, keep on hanging around. Oh, sorry, is this on? Or... Yeah, just checking. Okay, this is question time. So,
All right.
yeah, so you might want to take the microphone. Oh, yeah, that one.
Got the mic already.
Yeah. Yeah. So Dimitri, that's a very interesting presentation, and yes, it looks like ChatGPT just knocked off everything else. So we have to do machine learning anymore. Oh, that's a question, actually.
Yeah.
how is adaptive ML going along? It seems like we're still a million miles away from that.
Well,
But in classical and in neural networks.
yeah, I mean the adaptive I guess in what in what sense? The online learning model, I mean, that seems to be working pretty well. That's where you update the model coefficients as new data comes in, you know, without really any dynamics. For most problems, we don't know the dynamics, so you just, you know, wait, essentially mix the data, some window, all data gets forgotten. I mean, that thing kind of works. I mean, the reinforcement learning, well, in the restricted setting of the some sort of games, observable games, it's working pretty good. The outside of observable games like self-driving cars, that remains an open problem. Other forms of, yeah. I mean, yes, but maybe that was never the right paradigm. I don't know. Yeah, I don't have an answer on that. Unfortunately.
I guess my point of view from the big data to machine learning is that big data made machine learning viable because you could throw models with infinite parameter sets and you wouldn't have to deal with overfit. Is that something you'd agree with, I guess? Or is that?
Yeah. I mean, well, a lot of problems, like it's an interesting one. I mean, certainly big data in some sense, and by big data, right, it's really just the web crawl and libgen. Do you know what a libgen, library genesis? Are you familiar with that? Yeah, some of you are familiar. So all ChatGPT, that's the mysterious books 2 data set. If you're familiar with the anyway, nobody knows what it is. So in that sense, you know, the effort of, I guess, anonymous, largely unreported, let's call them librarians, right, has contributed a lot to the success of AI, by collecting the very large and of course the internet crawl corpus as well. So from that point of view, that's definitely big data that's behind it. When it comes to like consumer behavior data, like if you are talking about, if you're doing things like news articles, personalization, like if you're working with like news or recommender system where you have very large inventory that constantly changes, there isn't truly a lot of big data because things kind of rotate pretty quickly. But like there's probably not much value in remembering very old history for model training. But maybe there's some. When it comes to trying to learn personalization in like the kind of contextual bandit setting, you're really limited by your by your randomization policies and the strength of the effect of the interventions. Yeah, I mean, I think it was definitely useful technology, and having been able to store multi-terabytes data sets, you know, played a big part within a particular business. I mean, if you knew what you were doing, you could solve any problem in a consumer business in Australia without any big data. But of course, very often you didn't know what you wanted to do. So yeah, the hindsight bias as well. It's very strong. So.
I respectfully disagree that big data has been solved. It depends on the definition of what is big data from that point of view. We as a business went from 20 million to 100 million to a billion to 150 billion rows of what we needed to crunch. And then it is very much a problem. And Redshift and BigQuery were not able to solve it at once you're in 3-digit billions. And then you're basically only running Snowflake and Databricks against each other, and you're looking at a query of like $500, $2,000 at one query. If you don't optimize it and spend a lot of time understanding your data frame and indexing it right and all of these kind of things. So there's a lot of work that still needs to be done. I mean, it is solved at the very end of the distribution, but for a lot of companies, it's certainly still a problem. At least we have seen it like that.
Yeah. I mean, I think I said 99%. It's solved, but it depends how you count. I guess if you count by data volume, the 99% of companies would probably have close to 100% of all the data. If that makes sense. So 1% of companies would have 100% of all the data. So there is a definitely still use cases where it exists, but for like if you think, I think financial services companies with kind of frequency transactions similar to banks or for telcos, it's probably okay, at least in Australia. Like for certainly specialized use cases here. Further room for innovation.
Just thinking about the future, it seems like maybe the promise of personalization was never that critical. We're mostly interested in systems that do perform particular tasks, sort of stimulus response tasks, very well. And I think what we've learned from OpenAI's innovations is that very large language models trained on enormous corpuses are just very good language models, and you get similar results in images, and audio, and every other field. It seems like the future might actually be finding ways to recover commercial value from that. And personalization might be part of that, but it might also just be answering, narrow queries much better, or translating language or whatever. Is that maybe the sort of trajectory moving forward?
Yes. So again, it's hard to say, like, to kind of, but my hypothesis that looking more at basically causal inference in the absence of experiments might be a worthwhile direction. However, with ChatGPT, imagine if you could constrain the answers that you get from the large language model to kind of the data schema or the data model of your business, then you could generate plausible explanations to any performance anomalies, right? So the whole, like, if you're in business performance monitoring, like there was the like, I guess for a while, one dream was to provide answers to natural language questions, right? So you ask the question about the performance and you get the answer. But here you can get a convincing narrative about why the performance is great, right out of the box, right? So I think that is entirely plausible. Basically constraining the answers that you get to actually make sense within the organizational context, which could be very powerful.
I tapped out of the enterprise data science space maybe 5 years ago. And at that point, there had been all these legacy analytics tools in use, which were pretty terrible. And then R and Python came along, and that was going to change the world. And then people realized no one knew how to deploy them and monitor them, that kind of thing. And then these tools started to appear that were going to do auto ML and data robot and all that stuff. Have those made good on those promises, do you think? Those suites, like, are people in enterprises, in banks and insurers and things, pressing buttons and getting their models out, or is that not panned out yet?
Yeah, it's excellent question. The tools are they're really good. The problem with, again, data robot and the like is the limitation of, I guess, the supervised learning concept in the enterprise setting. There's only so much you can do with, like, essentially this pure, I guess, real prediction type tasks. So there seems to be, roughly speaking, 3 canonical use cases that I'm aware of, where there is perhaps some traction with this style of tools. And one is basically risk pricing for insurance, some sort of credit scoring, vaguely defined, and the third one is essentially demand prediction for FMCG. So those seem to be a bit narrow tasks where the tools seem to be relatively well suited. Like, outside of that, I don't know, like it's if you talk to people in selling those solutions, they just say it's difficult to find, you know, good, powerful use cases. A few ones that tend to repeat. So I think the tools are good, like they're faster than trying to start it with just the empty file. Well, although with ChatGPT, you know, again, it's maybe everyone can run the or similar technology with autocomplete. Maybe you don't need to know the intricacies. So maybe that's another threat angle. But yeah, I think those tools got really good. It's just that they haven't found their use to come up.
Hello, I'm over here. Thanks for your talk. One of the search terms that I think maybe might have a place there is data mining. So I'm curious where that sort of sits, or where you think it sits in terms of the trends, especially in industry, given that it's sort of more along like the unsupervised space and more the exploratory.
Yeah. Well, I think that data mining was kind of getting really uncool by like 2010. Mark, he was very old school. Eugene is nodding here. I don't know. I think it's a pretty cool term. I mean, you have the wealth of imagery with the T-axis and the gold nuggets and things. I thought that was pretty great. I love that.
My recollection of the data mining buzzword is it was just a previous brand and a far less successful brand than data science. Your identification of it with unsupervised learning is surprising to me, because being there at the time, basically data mining was a word for whatever it is that those people mucking around with, mostly supervised machine learning did. What was true was that at that time, there was very little clue as to what supervised or unsupervised was. And in some cases, people thought it was a 50-50 rather than the 99-1 that actually predominates in practice.
Over here. Thanks, Dimitri. That was a great talk. Comment first. I think there's a missing blip on one of those diagrams, is when there was the Forbes article in about 2012, that data science was going to be the sexiest career of the 21st century. That's the inflection point, I think.
I said, well, that's where it's off, right?
Yeah.
Maybe note.
That's the note, is it? Awesome. Second point, and I've got a lot of sympathy for your sort of focus on the causal analysis and where that can go. I think that's a really interesting space. And while I have sympathy for the idea that, you know, like controlled experiments, you know, obviously that should be the default, but there's certainly history there of situations like, so Judea Pearl uses the example of the fact that we can now associate smoking with lung cancer, and we were never able to do controlled experiments. And for that reason, it was this really long, drawn out conversation in the literature. And so I'm just curious, this seems to go to what you're talking about, sort of connecting a model to a sort of a business data structure. But how when you read through his examples, it seems like it's more than you can do with a single algorithm. It's like a sort of repeated iterative analysis that allows you to come to this causal conclusion in the absence of controlled experiments. I'm just curious, have you seen, what's the best thing you've seen in the literature that takes us in that direction?
Yeah. I mean, some of the things you can do, I guess, in the I mean, in terms of the most convincing, here, if there is no controlled experiment, you're really in the realm of what sort of argument is most convincing to you, or I guess the broad general or whatever, the broader audience, and how that can be constructed. I mean, probably the most convincing ones are the, like I guess you call them instrumental there's a simple DAG representation of those. Is like essentially random instrumental variables of quasi experiments. Like if you have some sort of regression discontinuity. So those, like to give you an example, like for instance, if there is if you're interested in the impact of years of school, well, I guess something to do with schooling on some sort of other outcomes, you know, like in reach different areas, they have different rules about when you're allowed to go to school. So children at just around, with birthdays just around the cut-off dates where there is no real reason for them to be very different, right? You know, they, due to kind of administrative rules, they end up getting different amounts of schooling. And then you can see how that impacts the outcomes down the line. So something like that feels like it's very difficult to truly automate the discovery of it.
Is that hunting for natural experiments in the data?
Yeah. So and that again, ChatGPT might be of help here. But yeah, it's finding those. Like what you can do in production, you can create some sort of I guess synthetic controls by if you have interventions applied, or somehow even before, after, or geographically, you can try to make things look the same, even if there is no real control. You can try and create a synthetic control from where things haven't been applied without randomization. That's potentially automatable. Yeah. But like having like just a wide list of columns, and then trying and generate sort of automated causal discovery from that, I mean, still seems fraud because there are a lot of like assumptions on the causals. I think it's just an area where tools need to develop. It's not that it's impossible.
Yes, it is worth mentioning. You're probably familiar with this, but it's worth mentioning that machine learning, supervised machine learning methods have been adapted specifically to these econometric methods, particularly instrumental variables. And I'm specifically thinking about GRF, or giraffe, which is an instrumental variables random forest, but there are others.
Just picking up on that point, I think there's been some concern equally from sometimes it's called p-hacking, of when you go searching for causal relationships, the more you search and the more powerful your tools are, the higher the risk, or the larger the number of spurious results you're going to get. And so sort of back to your point to think about the limits of automation versus coming back and kicking the tires on it afterwards.
Seems to me that the performance of the tools and the impedance of the tools is really what's holding us back. We need to improve. I mean, I'm a Microsoft guy, ML.NET. I can build models just with the library, millions and millions of bytes of data. We would take Python with the GPU hours and days to build. So, what about Julia? Why aren't everyone moving on?
Yeah. There's definitely at least probably. I guess it depends on exactly where in your kind of the pipeline you're looking for performance. I mean, some bits of the pipeline are pretty well optimized, so some and some are really not. It's probably less clear how much we can get. Like even if, well, for a lot of application, like if you think about like the general use, right, and especially the JavaScript kind of ecosystem, JavaScript UIs, JavaScript kind of rendering, client-side rendering, so those really manage to probably cost close to 2 orders of magnitude native implementation. It's not very noticeable. Because you're in the human in the loop kind of phase of the cycle. But I guess there is a lot to, if you think about end-to-end data pipelines, probably a lot to be done to push that to make it more efficient. When it comes to some of the training, network training loops on GPUs, is probably less without some architectural changes. yeah, but yeah, I think things will get better.
Okay, thank you very much, Dimitri. We'll draw that session to a close, and now you said that if you have less schooling, there's impacts. And I actually was a mid-year intake when I was in kindergarten, so I'm still paying that price. Only had a half a year at kindergarten. Anyway, we'll get back in here. We'll have a break, and we'll be back at 7:05. So if you can be back in here, the toilets, as I said, are down the hallway to the left there. Thank you.
Oh, hey, how you doing, man?
You got to come up?
I was running late. So.
Remember you being delighted.
I'm in a statistics group, so models, tweak them, see if they're better. Not quite in the big data paradigm, like they're better. Yeah, it's less about the application. I'm more about like Next, for example, ice from space, the ice from Antarctic ice. Right, so it's still a lot of real situations, but background is not. Yeah, I think so. I think data science. How do you think of that talk? For example, like parametric models where you know legs and heats and nags and having said that, being in a stats group, sampling and abstraction. Everyone's right. Definitely shocked. Bad I think keep on growing. We're on how much you how he thinks it does. Everything. Yeah, like what have you found? The process is not just about science. Generalized. How do you tell what it's like you said, it gives you a very clear answer to the question you want. This is start to talk this like this. This new software thing, whatever metric is very specific. Like AI and ML, in my opinion. Scaling up so general API. And like you like kind of surprising because everyone I thought was kind of like general intelligence kind of picking it up like GPT. It's just you can do anything. All of a sudden now we're saying, no, let's go back to the legend, which in my opinion is is hard and also different in 6 months trying to understand the objective area, like is it's a distracts of these experiments, collective experiments, test hypotheses that involves like fitting these like complex statistics, and then the crispy answer is yes.
We're trying to do the impossible against the best.
Yeah, I'm trying to use some of that, to be honest. Yeah, like I'm quite excited about yeah, so I'm going to try to use should know each other. So it's like very effective. It's like beginning ground. But essentially what it says the new paradigm it's not if you did neural network or it's actually every tip now secondly I'm trying to like like he assumes about the success of big data because that's led to training without real. That's what transformers are made of. Big data set. Data that you don't have to at a university, data sets and
if everyone can take their seats, please.
so I want to use it,
Quite well, I can tell you. Artificial intelligence learning the new but some other general situation that is not defined in smaller model sets outside those problems. That's an artificial another side. As the
With all the water you guys are entitled to, it's like, this is Mad Max all over again.
That's a good example of the machine learning.
Okay, I will start. So Eugene doesn't need another introduction because I introduced him before. But Eugene's talk is data science 3 years on, ChatGPT, some use cases and implications. Thank you, Eugene.
Well, don't know how to start this one. A few things to say. First thing is it's emotional. It's a little overwhelming. It's a real pleasure to see so many familiar faces, old friends that I have seen, not enough in that rather unfortunate time that we've had over the last, 3 years. And some of you that I see very gladly and I haven't seen since then. So yeah, very, very happy to get Data Science Sydney running again. And this is time to acknowledge and thank the Institute of Actuaries for making this possible. And, you know, let's be honest, the Institute of Actuaries is an abstract institution, very kind, very necessary, very important one. It's the people that matter. And there are people in that institute that are helping us tremendously. There are people in here now that are part of the organizing committee. There are people here now who are performing the logistics of making this possible. too many names to mention, and I'm probably too old and stupid to remember them all. So thanks to them all, but there's one name that stands out, and this is the name that really has to be thanked for making this all possible, because the man who has been twisting my arm for the last year to make Data Science Sydney happen again is Bill Constantinidis. So thank you so much. And since we're doing acknowledgements, I think the next thing I need is to do an apology, and the apology is to Dimitri, and it's heartfelt. And it goes like this. Dimitri, I said to him, would you like to present? And he said, yes. And then he's very enthusiastic. He said, look, here's some slides. And I look at his slides. I go, Dimitri, you know, it would be good if they were more visual. He goes, oh, no. Okay, what am I going to do? How about this? Slightly more visual. And I'm sort of, you know, going, maybe change this, maybe change that. The big apologies. Well, Dimitri sent his final slides to me today, and he said, are these all right? And my reply was, wait till you see my slides. Those of you who know me know that occasionally I do this extemporaneous thing. And the reasons are mysterious, right? The reasons could be that I just have something very sudden and very important to say. The reasons could be that I'm okay with this whole extemporaneous thing, or the real reason could be I'm so damn disorganized that the slides weren't prepared. Maybe we'll do a survey and see which one of these you think it is. So, really glad to see everyone here. And let's now talk again about those last 3 years, because we need to talk about those last 3 years in context. They've certainly affected me in many ways. They've affected me professionally. They've affected me intellectually. They've given me a lot to think about, a lot of unpleasant things to think about, to be honest, as well as some interesting ones. So what happened? Well, 2019 happened, and it hit all of us. It hit all of us in its own way. 2020, that is, right after 2019. And I'll refer again to Dimitri's talk, because there were things he brought up that were real amen moments. And one amen moment for me was his, I think, penultimate slide, or maybe his third last or second last slide, where he talked about the fact that the real business questions, where what we do as data scientists can deliver the most value. These are the causal questions, the causal inference without experiment, without the benefit of randomized controlled trials. And quite rightly, Dimitri was saying that yes, there's all this computer science-y, and I'm assuming he was talking about mostly Judea Pearl. It's all wonderful maths, but there's very little you can actually apply. Whereas all the interesting applicable stuff is in epidemiology, it's in econometrics, it's in social science. I was raving about that. I was thinking the future of data science is non-experimental causal inference. And I was talking to Tiberio about this, because Tiberio is the man on this very topic. There he is. We'll make it present on this again. But you know, I thought, yep, this is what's going to happen. Yeah, then COVID hit, and we had other things to think about. So COVID hit, and what happens with COVID? Well, our lives all get rather unpleasant very quickly, rather uncertain. And by the way, the certainty issue is something we should think about as data scientists, because it turns out that a lot of what we do is really about certainty, or the lack thereof, and the impacts in that context. Not really the topic of my talk, but something to think about. Since we're here, I mean, why is there an Actuaries Institute? The word I was hoping to hear more is the word risk. So I think actuaries exist because quantifying risk is A, hard, and B, vital. So there's a whole profession around it, and C, not something that the average Joe can do. So anyway, something involving uncertainty and risk happened. There was COVID. And apart from the fact that suddenly we had the fear that a whole lot of people could die, that, you know, the old and sick people that we love could die, that horrible things could maybe happen to us, we then had the prospect of economic upheaval. And frankly, I very quickly became more concerned about the economic upheaval, which was kind of a fear response to something that may or may not be scary, may or may not be real, than the thing itself. I think you'll all agree with me that we were more scared than was, in retrospect, warranted. Maybe you don't agree with me, that's fine. I think you'll also agree with me that the economic impact of that fear was at least as profound as the health impact. I'm not saying there wasn't a health impact, but there was an economic impact. But there were other things. So that got me concerned. You know, that certainly kept me awake at night. Maybe it kept you awake at night. I was watching what was unfolding in the United States from about May 2020. I think you all know what I'm talking about. There was social upheaval, and you just had this growing wave of riots, anarchy, and you also had interesting things like a very interesting historian who did very interesting quantitative analysis, quantitative projections, a fellow called Peter Turchin, I forget which university was based in the United States, who had some years prior predicted that social upheaval would be at its peak in 2020. And so there it was. So I'm watching COVID, I'm watching economic upheaval, I'm seeing massive social upheaval. Now, all these things certainly got my blood pressure up, but none of them got my blood pressure up as much as what happened in, I think it was June 2020, which was the advent of GPT-3. Who remembers the advent of GPT-3? Just hands. Who felt like, yeah, that was the most impactful thing that happened that year? Who felt that that impact was overwhelmingly a good thing? You wasn't trying to annoy me. Well, who would say there is certainly doubt? In other words, we can predict the magnitude more easily than the direction of the impact. Well, that was me. That was me. I felt like this was a year of risk. So I had my own little reflections to make, because I was on podcasts and giving presentations about how neural nets are great, but they'll never really get there. I was an idiot. I was the one saying neural nets, brute force neural nets aren't going to give us artificial intelligence. Come on, we're not going to get sci-fi grade AI with neural nets. We should all be looking at causal inference. What an idiot I was. I should also point out that someone in this room went from a very strong background in Bayesian statistics, causal inference, and said, no, it's all about the neural nets. And he's the man, Sachin right there. So Sachin, you was right, I was wrong. And not only was Sachin right, my reflection on 2020 and all the things that I was observing happening, I figured if I was ever good at predicting anything, and I'm not saying I ever was, I certainly didn't have the knack anymore. So either I've lost the knack or I never had it. The world had, to me, suddenly become a very difficult place to predict. Uncertainty was increasing, and it was increasing across a whole lot of dimensions. By the way, I keep wondering if a number of other things that happened to us, like the supply chain crisis, could be at least in part explained by a decrease in the ability to predict effectively, at least for a period. So, but all I really want to say, the punchline of all this is that for me, the biggest impact of 2020 was GPT-3, because suddenly science fiction was real. Suddenly, a whole bunch of things that I can't quite enumerate in my head. They have to do with in context, and they have to do with various tests and so forth. Things that experts would tell us that an AI wouldn't do in decades, and that the fundamental things about being human, which were still so far out of reach of technology. Well, suddenly we had technology achieving it. We had technology jumping it in leaps and bounds. Suddenly we were having debates that I didn't expect us to be having for decades. And that was GPT-3. And the biggest surprise was that we got there with just brute force and scale. The biggest surprise is that we didn't need to find some sort of magic God formula for what a soul is. No, just okay, it's a 21st century version of the backprop algorithm at scale. An architecture at scale, a data set at scale, and a problem, and when you think about it, a stupidly simple problem of just predicting the next token in a text. So I was surprised, I was wrong. And that was 3 years ago, folks. And what was interesting to me is how relatively quiet GPT-3 was, where if you weren't in the know, people weren't interested. But it seems to me that what the web browser did for the internet, because the internet had been around for decades before the web browser came along, what the web browser did for the internet, ChatGPT did for large language models. Because no one was talking about, when I say no one, no one that matters, none of us, apart from us. Yeah, so, people in the media, people in governments weren't really talking about GPT-3, but along came ChatGPT, and here we are. What's interesting is how many people who are lay people, who are not data scientists, who are not computer scientists, who are not machine learning neural nets people, are talking about alignment. They're talking about friendly AI. They're talking about AI safety. I always thought those topics are going to be, well, they're for rather curious nerds. They're really, sci-fi value. But here we are. These are questions that I think are as material to our survival as a species, not into generations in the future, but years ahead, like 1 or 2 years ahead, as material as the protocols we developed for nuclear disarmament, for example. I think it's just as immediate and just as material. We're suddenly wondering if and when we're going to get artificial general intelligence. We're suddenly asking if the things that we're already playing with, the generic chat GPT or Sydney, as we've discovered, whether Sydney is actually conscious. We're asking these questions. Well, it was only a year ago or so that a Google research scientist claimed that their LLM was conscious. By the way, whatever does that word mean? But the thing is, it's only in the last week, I think, that we suddenly got an article in some respectable mainstream publication that's asking another question, which is, I think, a very natural question, which is, well, if we've got something that's potentially conscious, and not only is it conscious, but it's conversant with us. It certainly can emulate a human being, but isn't that all human beings do? Emulate human beings? I mean, how do you know that a human being is a soul is taken on faith? You can't empirically find one. Are we enslaving AIs by running them? Are we killing them by shutting them down? Well, these are the questions that are currently being asked. So I'm trying to give you the impression now that I have no idea what I'm talking about with this topic. I'm as lost as you, and we have no more authority on this stuff than anybody else, quite frankly. So here's something else that GPT did, what LLMs did. Is there anyone in this room who has developed an LLM with hundreds of billions of connections? I can guess what the answer is with high probability, but I still wanted to check. Folks, I've built plenty of machine learning models in my life, as have many of you, right? And I think you'll agree with me that there's a fundamental difference between being the person who builds models and being the person who uses something that's got models under the hood, because these days, everything that we use on the web has some machine learning under the hood. So just because you run a Google search, that does not make you a machine learning engineer, agreed? And, when I did my PhD thesis, the stuff I did was very close to a particular component of one of these. And I'm not just saying a smartphone, but a phone. But you know what? Knowing that stuff gives me no more authority over using an iPhone than it does any of you. We're all users. I'm a user of the iPhone. I'm not a telephone engineer. I never made the iPhone. Yeah, I'm just a user. And the thing I wanted to note is that with the large language models that are being made available to us, we're all users. Yes, there's all this talk about prompt engineering. We'll get to prompt engineering in a minute, but I don't know that, well, some people are going to be better at it than others, obviously, some people are, but it's a different domain. None of us are data scientists in the sense of being LLM users. We're all just users of a technology created by someone else. First question I just have a bunch of questions. My first question is, who has used ChatGPT or even GPT-3 or Sydney or any other? Actually, a better question is, who hasn't used it? Who hasn't used any LLMs? Interesting. Thank you. Are you thinking about trying it? No. Okay. Who uses it regularly as part of their work? Okay, so we're going to do a keep your hands up exercise, and I hope it's not too much of a workout for you. So hands up, everyone who uses it in their everyday work or their everyday activity. Someone who uses it regularly. Well, presumably you've all used it for content generation. That seems to be the most common usage of it. And this can be anything. This can be articles. This can be ads. It can be sometimes helping you write emails. And you can be creative with it too. You can use it to write stories, fiction, write poetry, write songs. Has anybody written fiction with it? Anybody written fiction with it? Yeah, what have you written?
It was a short story about my 2 cats and a patch of rhubarb.
Who won?
The cats were heroic. They saved like the rhubarb crop, and the villagers hero worship them forevermore.
You'll be hearing from my 7-year-old son's lawyers, because he's got a story about our 4 cats and a magic carrot. So content generation is perhaps the most accessible and the most easy to explain application. And I think it's certainly changing some people's lives. Who's used the content generation stuff to summarize, to try to explain things? And who uses it for their own purpose, just to explain it to yourself? Yeah, me too. Who's used it as a tutor? Who's used it as your own little guide? Yeah. Who's used it to build tables of data? Yeah. Now, the interesting part is the other side of it, which is code generation. Who's played with it as a coding tool? That's interesting. I think there are more hands on the coding than there were on the content. By the way, keep your hands up if you use it for coding in your actual work. Yeah. Now, apart from just, hey, write me the code to do blah, usually in snippets, who's used it to translate code from one language to another? For better or worse, I'm an R user. And that was not a great bet, was it? But with ChatGPT, it doesn't seem to be a problem anymore, does it? Because anything I write in R can be easily translated to Python, or vice versa. Who uses it for code explanation? Because just as you can explain an article, it explains code. Who's used it for code refactoring? Here's my crappy code. I wanted in nice functions and nicely articulate. Small guys, highly recommended. Highly recommended as code refactoring. And I guess the one we're all here for, who actually uses it to do machine learning? So I have to say, for me, that's the one where I've encountered the most disappointment. I think those of you who use it regularly for coding, you've probably found that it makes mistakes. It doesn't know when it makes mistakes. It's also, it's a little like a 7-year-old or a 5-year-old in some ways. It kind of sort of knows it's lying, and it kind of sort of doesn't. When you catch it, it'll kind of sort of lie a different way until it finds the truth. And it's not quite sure it knows the difference in truth and lying. And anyway, yes?
No, it was meant as a language translation tool.
Was it?
Yeah, originally. And then it became data. So the data part is still nascent, still learning that part, but the translation part's there. So it's like, it has to develop heaps more.
Well, whatever we know about GPT-3 and ChatGPT and OpenAI's efforts, I'm sure there are going to be alternatives. I'm sure we're going to be hearing about radically different approaches to LLMs. What worries me are the ones we're not going to hear about that are being done anyway, and that's another question. What is the real state of the art of this stuff, and what's that being used for? But yeah, I have more questions and answers. My experience of the machine learning stuff is the more obscure the thing you're trying to do is, the more likely it is to start making errors and lie to. And I have recently been doing rather obscure things. And yeah, I can tell you it's with XGBoost, and I can't tell you what I was doing with XGBoost. I'll be giving away some of our secret sauce. But the point is, yeah, it was good enough to point me in the right direction. So even when it's wrong, it still manages to at least put things in your mind, some function.
Gene, does it save you time? Does it save you time?
Does it save me time? Yes, except being an ADHD type, I will go down the rabbit hole of having fun with it. So theoretically, it saves me time. Theoretically, but it's not just a matter of saving time. It actually gives you qualitative difference. It gives you things you wouldn't get even if you put more time in. Like it just fine. And yeah, the whole tutor and summarization thing is amazing. The ability to explain code is amazing. Anyway, who's tried to jailbreak it? Who's tried the Dan 5 stuff? How'd you go? Who's tried to break Sydney? I don't believe you can anymore, do they? So there are so many things we can all do with it, and that's great. Yeah. Now, wouldn't it be great if you woke up one day and in 2020 and OpenAI came to you and said, hello, search your name here. We've chosen you as the lucky recipient of this amazing tool we've built, which no one else can use. You get to use it, no one else does. You'd be democratically elected president of the world in no time, if you believe in the virtues of democracy. But the point is, if you and only you had access to the magic of GPT-3, of LLMs 3 years ago, imagine the things you could do. If now you were the only person in the world who had the access to Chat GPT, imagine the things you could do. Of course, that's a crappy little hypothetical, because the truth is everybody has access to it. So the question is, what does the world look like when everybody has access to this? What is the impact on our lives? And of course, specifically, what is the impact on jobs? Because on the one hand, suddenly doing stuff has become more easy, more fun, and more interesting. That's true. Okay. But is that party going to last? Or is the world suddenly going to become very strange and competitive? And are we going to discover that a whole lot of stuff that we thought needed people doesn't need people anymore? And the people left are people who can do really, really, really amazing things, at least temporarily, until the AIs get more amazing. I don't know, but it's worth asking, isn't it? I think it's, as I said, I think it's important to note that you've got this amazing technology now where we're all users. You know, there's a small number of privileged elite LLM builders in these very large organizations, and the rest of us just use their stuff. There is this new buzzword. Have you noticed, folks, when change happens, buzzwords appear. The buzzword I'm talking about is prompt engineering. Now, how many of you think that buzzword deserves to be a buzzword? And how many you okay, that's great. All right. Well, I'm sure there are already job descriptions out there that say wanted prompt engineer, lots of money. I'm still not sure what exactly the skill set is. And more importantly, I'm not sure how stable that skill set is going to be. Well, however, I do, in parallel, I do think that how we prompt LLMs is going to be a pretty handy skill in the future. So I don't know. I'm torn on the whole prompt engineering thing. But I still want to know what is going to be left for people for people to do. I also wonder how much of the prompt engineering is going to be done by LLMs rather than people. Like, if you think you're a great prompt engineer, what makes you think that GPT, 3 plus, add a number, GPT-5, GPT-6, what makes you think that some future LLM with some sort of reinforcement learning layer over the top of it, and possibly some other miraculous kind of AI we haven't even thought of, perhaps something to take care of its ability to do logical inference. What makes us think that that won't do whatever it is that you think you can do as a prompt engineer? Well, I guess what we're talking about here is the whole singularity idea. So let's talk about the worries that come up. So the positives. Well, I'll try to finish on the positives, but the worries are, first of all, there's a trivial one, which is I actually think a whole bunch of jobs are going to disappear. Now, I think it's very hard to argue against that one. The counter argument is yes. Well, it's not a counter argument. It's a yes, but. It's yes, they'll disappear, but they'll be replaced by wonderful new things that people can do. Well, that's if you believe that all human beings can flourish into more complex ways of thinking when the simple stuff is taken away from them. I don't think that's true. Maybe you do. And I have some friends, hello Jovan, that I argue with precisely on this topic. So I don't know what's true, but yeah, there are opinions. So I think there is change coming. There is change coming for people. I think there's change coming for people who write content, sort of unaccountable content that never has to meet reality. And there's change coming for people who write code without any interest in sort of the business context or the validity of that code. There's some very interesting change coming, interesting in a may you live in interesting times kind of way, interesting change. So what are the real worries? Another worry is that we just might get an agentic, which is to say, has its own purpose, has its own interests, and acts according to them. AI that's misaligned, that's unfriendly. So this is the Terminator scenario. So one horror story is that we get a Skynet. In fact, you know what? That's not a horror story. That's a good outcome because there's only one of them. I can see lots and lots and lots of them. So that's one. One that's possibly even scarier, depending on how you look at it, is what people call the singularity. So how many of you folks here don't know what I mean by the singularity? So, how you doing? How many people not called Aiden? Honestly. So the point is, let's not worry about whether it's evil. In fact, let's be grateful if we get an evil AI, because at least if it's evil, it still lives somewhere in our moral framework. It still has a role and an attitude to human beings as mattering. If it wants to wipe humanity out, at least it kind of thinks humanity matters in its story. Whereas with the singularity idea, you got AIs building AIs smarter than themselves, who are even better at building AIs smarter than themselves ad infinitum, much, much faster. And after a few such iterations, it's not that human beings are in trouble, well, they are. It's that human beings no longer matter to what's happening in the world. Human beings are in the same place as perhaps the bacteria that populated the world when the world didn't even have oxygen. The earliest living things that died out as they created the next generation of living things. That's the singularity scenario. That's not a nice thing to think about. And then you can turn it around completely and go back to something I mentioned that's been raised in the media, which is the ethics question, which is the whole question of, well, if we've created something that's conscious, that it says it has feelings, certainly interacts with us in every possible way that a human being interacts with us, and tells us the kind of things a human being tells us along the lines of, I want this, I want that, I'm happy, I'm sad, etc. Do we have a right to enslave it? Because that's what we're effectively doing. So these are the worries. But I wanted to end my little ramble on the positives. It's not usually my style, personally. But yeah, I'm told this is a way to win friends and influence people. Well, I think that the interesting thing that we've got with large language models is that there is now something there are now far fewer barriers to success for people who have a certain kind of cleverness and vision. And the kind of cleverness they need is just to be able to articulate their vision, possibly in an iterative way. It means that if you can't code, and more generally can't do aspects of engineering, or even you don't have skill in a particular area or skill or knowledge of a particular area, if your problem is a lack of coding skill or a lack of domain knowledge, but you have an actual overarching vision, this thing can help you get there. But, if you can't actually articulate a vision, and you don't know the difference between, on the one hand, a vision, an idea, a structured plan, and on the other hand, a bunch of buzzwords. And by the way, I keep running into people who don't know the difference, and they're very senior. I think there's one group that now does not need a middle management layer, and certainly doesn't need frontline coders and engineers the way they used to. And there's another group who's in a very interesting place, because there's suddenly what we tell both groups: look, if you're a manager, if you're an entrepreneur with vision, and you know what you want, there is now a way for you to articulate it and make it happen without the need of an expensive, hard to manage, and poorly communicative IT resource, engineering resource. And I think we're going to see a bifurcation between the two groups. We're going to see that there's a bunch of people who are going to absolutely flourish. Absolutely flourish. They're going to learn what they need to learn with the help of LLMs. They're going to generate whatever code they need with the help of LLMs. And there's another group who are going to discover that they never had vision in the first place. So the near future, at least, belongs to people who can prompt AI successfully. And when I say prompt AI successfully, this is the prompt engineering thing. It's really this ability to articulate one's vision, iterate according to one's vision, and iteratively learn with the help of an LLM to plug up the gaps in one's vision, to sort of test one's vision and plug up the gaps in it. I think the near future belongs to the people who can do it well. Who knows what the medium term holds? I think Dimitri was wondering if we've got 10 years. I think you may be optimistic. So I think that thinking clearly in a logical, structured manner and being able to iterate, being clear on where your ideas are fuzzy and where your ideas are clear, being clear on where your ideas are proven and where your ideas have been successfully challenged. For those people who can do that stuff, the barriers are now lower than ever. Their biggest problem is that they face massive competition, because everybody who can do this can now do this. For everyone else, I think it's going to be a pretty challenging time. So that's the end of the ramble with no slides. I will accept one question from Greg, because Greg is an old friend. I will preface it by saying that I was going to accept no questions at all. And I was going to suggest that if you really want to ask questions, you can come and ask me after the talk, or you can look me up. I'm not that hard to find, but Greg's an exception. Greg's a great guy, and Greg is an amazing recruiter, by the way. So if you need a new job, go and talk to Greg. Over to you, mate.
Eugene, thank you. It's just a very quick question. And obviously, you with a young family, where does ChatGPT sit within the schooling and the university environment, do you think, moving forward?
My brother limits screen time for his, you know how many kids my brother has? He's got 6 kids. My brother limits screen time for his preteen and teenage kids. I gave my 7-year-old a Mac. In fact, he was 6 at the time. I gave him an older Mac loaded with the language Scratch. And Scratch is a visual block-based programming language for kids. It's amazing. I showed him how to start it. I showed him how to launch the tutorials. I also mentioned to him that there are Scratch tutorials on YouTube, and I said, go to town, kid. He's been hooked on it since. My 7-year-old has written, admittedly with the help of online tutorials, for those of you who know what asteroids is, and here I'm showing my age, he's basically written a color and much more interesting version of asteroids, except the asteroids are lemons. It's called lemonoids. So you blow up a giant lemon and it becomes smaller lemons. He's added an effect that you get lemon balls flying out. It's really good. So he started improvising. He's now built it like a 3D first person game, or the makings of one. He's now building something he's calling his world game. It's going amazing. I haven't shown him I haven't shown him GPT-3 yet, but I've shown GPT-3 to his 11-year-old cousin, one of my brother's kids. And he says, yeah, it's amazing. Again, I think having done a PhD, I don't think it sets me apart in any way. Okay, it doesn't. The PhD, however, the one thing a PhD did give me, and I think if a successful PhD gives you, it gives you a superpower, and that superpower is the ability to learn on your own way. It's sort of self-guided learning. Now, there's no need to do a PhD for that. I'm trying to give that to my son, and that's why I think ChatGPT is going to be a big part of that. So thank you for your question. Thank you very much. That brings me to our final speaker. Let me introduce Sachin. Yeah, okay. Sachin, you've got about 10, okay? All right, so we have a surprise speaker, and it's a data science that he regularly, you must have presented like 5 times to the court, at least. And I apologize for never remembering his last name, but it's the first name that matters. His first name is a brand. It's Sachin, folks, and he's going to tell us about a visual generative AI.
Break. Otherwise, like Eugene did, so I'm not going to do that. So
we ask you questions that were meant for Eugene instead.
Yeah, that's right.
More questions for Dimitri.
Oh, let's back up.
Do you think we have 10 years?
Maybe. Yeah, okay, so I'm going to be talking about stable diffusion. Just before we start off, can I get a who knows what stable diffusion is? Who's actually played with stable diffusion? Okay, all right. So just to give you a bit of context with people who don't know what stable diffusion is. So forget about the stable part. Diffusion models is, I think, has been getting popular for the last 5 years or so, especially the last year, since stable diffusion came out. But it's basically a model that generates. It's a model that generates images, right? So, and this is my talk about how I hacked stable diffusion to do what I wanted to do. So, if you go into a demo, so you can there's quite a few demos of stable diffusion floating out there. Let's go to one. If you type in Sachin, which is my name, you get this. So for people who are familiar with cricket, this is Sachin Tendulkar. So he's a famous Indian cricketer, and as a Sri Lankan, this is quite offensive. And okay, so this is how I managed to get it to show me instead, right? All right, so very quickly, this is what a diffusion model does. It starts off with an image. You add noise until you get to completely noise, and then you build a model to reverse the process, right? So you add Gaussian noise, but unfortunately, the other way is not Gaussian. Stable diffusion. Okay, so to explain this thing very quickly, it has 3 components. You have the red part, which is the so over here, if you see, it's the pixels that are being noised. in Stable Diffusion, the trick that they did is instead of doing on the pixels themselves, they had autoencoder and went to a lower dimensional space, and they added noise to the lower dimensional space. So that's the first part of the model. The second part of the model, the green bit, is called a unit, right? So the unit, what it's trying to do is trying to predict the error, right? So you're trying to denoise what you start off with as noise. And the last component is this thing, the conditioning, right? So it's usually text. So in Stable Diffusion, it's definitely text, but it doesn't have to be. It can be images, it can be more sequences of images, whatever you want it to be. But yeah, so in Stable Diffusion, it's images that's feeding into the unit, and you work yourself backwards to try and get back the original. That's not what this talk is about. That's going to be an entire talk on itself. But just to, okay, unfortunately, okay. So this is what I'm effectively trying to do, right? So if you're familiar with PyTorch code, given the current noise that we have, and given the current time step, and so this is the text as numbers, right? When you encode it into numbers, you pass it through a unit, you get a noise prediction, and then you try to minimize that loss. That's all this is when it comes to fine tuning, right? So once I did all the fine tuning, these are the better images that I got. So this is what a Sachin looks like. Okay, so yeah, this is Sachin in ancient Japan, and this is Sachin as a Terminator. That's me. If you want the actual code to play around with it, I'll put a link to this. It's called, the method is called Dreamboot. Dreamboot is not a model, as most people think it is. It's a method. And just lastly, a very shameless plug. I will post a link to this as well. It's a free link to my course that I've put up. That's it. That's me. So thank you.
Do you want to take questions, Sachin? One question, and then we do announcements.
Greg?
Questions. All right. And now it's the closing period where we open the floor to anybody who has relevant announcements. And relevant announcements are things like primarily job offers. So great time for Greg to talk about what's out there. Also, any other similar announcements? Has anyone written a book? Is anyone doing an interesting event? Whatever the heck you want. If you think it's relevant, come on out and announce it. We've got 5 minutes, I guess, before they kick us out.
All right, I'll go quickly. I don't need the microphone. It's good to be back in front of you all again, because Eugene and I have been doing this since 2012, and then we had that little bit of a break, which is great. And yeah, so I work with a company called The Onset. We're a technical recruitment business. I head up the data science area. If anyone obviously is looking for advice, understanding of the market, or people are looking to hire some really good people out there at the moment, there's a lot of change in the marketplace, obviously. Atlassian today announced a number of redundancies, but look, when redundancies happen, opportunities happen as well. So please feel free to reach out. So you can reach me at Greg Pearl at The Onset. We can just have a look, but I'd love to have a chat if anyone wants to.
Thanks, Greg. I have an announcement. We have a surprise mystery guest, who is the co-founder of this group, Fabian Held, ladies and gentlemen. Man who I think is far too quiet, given his accomplishments and abilities. And yeah, this group would not be possible without him. So,
I can just echo your sentiment. This is kind of really emotional, seeing you all again here.
Give the man a microphone.
I'm just glad to see you all again. Thanks for convincing me, running it again. So thank you as well for making this happen.
The inestimable Luke Metcalf.
Luke Metcalf here, founder of Microverbs. Today we launched an API which makes available tens of millions of data points. So anyone with solving any kind of customer analytics, kind of geospatial kind of thing. So if you want demographic or any kind of amenity data, a huge amount of profile data that you wouldn't expect, discrimination, alienation, pricing of real estate aspects are all available through our new API. Almost it for cheap, not free. There is a free tier.
I believe someone's got a cookbook.
Yep, over here. So Aiden here. I'm in the Young Data Analytics Working Group for the Actuaries Institute. And what I want to talk to you about is Analytics Cookbook. So this is kind of a GitHub page. It's a really good introduction for anyone who's looking to get into data science from the actuarial field, or just anyone looking to learn a bit more about some code for practical for actuaries, but also regular data science stuff. So if you Google Actuaries Institute Analytics Cookbook, that should get you there.
And I don't want to put pressure on anyone, but who thinks Luke should present on Microverbs in the new API in Data Science Sydney in the future? Don't put too much pressure on him.
All right.
Luke is very shy. And I've got someone else. I don't want to put any pressure on and give names at all, but who might be interested in hearing about Bayesian causal networks and modeling warfare? Hands are going up. Sorry, you're going to have to present. All right. I think that's it for announcements. One more, yes.
Saying I do ML, Microsoft ML.net. Like I said, build models super fast with shitloads of data. I'd be interested in seeing if anybody wants to join me in a group to compare with what I do with what you guys do, you know, in Python. So yeah, so any kale competition, stuff like that.
Python, I'm out. Is that it, folks? Can I go home and see my 7-year-old before he goes to sleep? Thank you very much.
Thank you, Bill. Thanks.
Nice to meet you. Having a meal.
I don't know when it get sucked today. Hey, Boris, hang on, mate.
At some point, though, there's going to be.
Oh, okay.
Yeah, we were bought out by a private equity company, no longer a public. Same company, same strategy.
No,
That's not
looking for